20-second shutdown warning. Now, how's that for safety?
It's actually pretty bad. Today we're going to be looking at another one of Mustard's videos, specifically the nuclear flying carrier, Lockheed CL-1201, with F-4s on its wings. Wow. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry, from engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's check this out.
In 1969, the U.S. government launched one of the most unusual projects in the history of aviation. It had only two objectives: determine just how large an aircraft could get,
1,120-foot wingspan. That's big.
demonstrate what it would mean for U.S. air power. Spearheaded by the most secretive company in aviation, the result was the Lockheed CL-1201. A project that, to this day, remains shrouded in mystery.
Now I see where Ace Combat got their ideas for heavy command cruisers, or whatever they called these.
The 1960s saw breathtaking advancements in the field of aerospace.
Was cool.
Aircraft were flying faster, higher, and further. And engineers weren't just pushing the limits of speed. Aircraft were getting larger. The newly developed Lockheed C-5 was a massive machine weighing several hundred tons. Its power and range dwarfed anything before it.
I'm too young, but the Cold War must have been an interesting time for engineers with all the crazy projects, all under the banner of surpassing the communists and flexing your military muscles. There it is, nuclear power, just as large transport. Look at all those wheels. And I like how the tail fin is half the size of the C-5 Galaxy. That's
advances in aerodynamics, exotic new materials, and even new forms of propulsion were just around the corner. Much of the breakneck pace in development was fueled by the Cold War.
Yes.
With the United States and Soviet Union vying to gain the upper hand, huge sums were spent developing spy planes that could fly faster and higher, and bombers that could carry more payload further. The aim was to reach any corner of the world as quickly as possible. To counter the expansion of Soviet power, the United States maintained a strategy of containment. And that meant maintaining a vast fleet of carrier battle groups that could respond to a crisis anywhere in the world. But as the Cold War intensified throughout the 1960s, no corner of the world seemed safe from Soviet agitation.
Gotta respond even faster by making your carriers fly.
To respond quickly and decisively, the United States looked to radical new technologies. By the 1960s, the Lockheed California company was developing the world's most advanced aircraft, pushing the technology of the time to its absolute limit. And they had worked with the Navy and Air Force to evaluate new technologies and develop the next generation of military aircraft, much of it highly classified.
Love the SR-71. It's got such a retro-futuristic vibe to it.
But in 1969, the company produced an unusual study that seemed out of place even among its cutting-edge research. It detailed an aircraft with monstrous proportions, at nearly 6,000 tons.
That's insane. I mean, I'm not an aeronautical engineer, so that's 4 times the wingspan of a Boeing 747, more or less. And one universal engineering principle is the square cube law. So at its simplest terms, quadrupling the length, times 16 the surface area, and times 64 the weight. And that's just if it didn't go anywhere. You're going to need to add more weight to give it powerful enough engines to take off and sustain flight. And being able to design an airframe to maintain the required level of lift is crazy, not to mention drag force, turbulence, simple flight stability on something that looks like that at that size. It's probably would require some pretty advanced materials and structural engineering techniques. So I can see how it's well over 5,000 metric tons.
And with an 1,100-foot wingspan to serve as both a military transport and an airborne aircraft carrier.
Airborne aircraft carrier. Look at the normal-sized 4-engine plane docking there just for scale.
Yet today, surprisingly little is known about the project, because Lockheed's study has...
I like the presentation of this. It's got this whole... Again, everything about this is retro-futuristic. I love the aesthetic that Mustard chose.
vanished without a trace. Even the U.S. Department of Defense has no record of it, as if it were somehow lost or erased from existence. But over the years, Lockheed's design has been cited in several other aerospace studies, including a report from 1982 that provides just enough detail to piece together one of the most unusual aircraft ever studied.
I like that.
With a payload capacity measured in the millions of pounds, the Lockheed CL-1201 would represent an...
That's a weird unit, millions of pounds. I mainly just think of tons, whether you go metric or imperial, when you get onto that scale. Must be an aerospace thing.
Entirely new class of aircraft, giving the United States the ability to deploy several hundred fully equipped troops and armament to anywhere in the world within hours,
the engine's on the
or
top
launch
too.
Dozens of heavily armed combat aircraft on a moment's notice. And Lockheed's engineers outlined a scenario where these capabilities would be vital for the United States. They envisioned an organized uprising halfway across the globe, instigated by the Soviet Union. Responding to a call for assistance, the U.S. would typically deploy a carrier group and Marines to help stabilize the situation. But in Lockheed's scenario, the Mediterranean would be blocked off, and nearby foreign bases would be unavailable. So the 1201 would provide the only means for a rapid strike with a sizable force launched directly from the continental United States.
You could even just have these, I mean, if they're nuclear powered and allegedly have a super long fuel cycle, you can have these effectively just patrol, be airborne. Also, how big does this runway need to be to launch one of these things?
And to explain how this would all work,
it's called Attack Aircraft Carrier. Also, is there a way to get out when you dock your F4 on this thing, or are you just kind of suspended in there when you take off? There's got to be some sort of pod. I can't quite tell in this picture. Maybe they'll get to that in a bit. That's got to feel weird to be in a plane and then your big plane takes off.
I've brought on a former BBC News presenter.
Cool. Oh, I love it. Let's get fully immersed in this aesthetic.
Oh, hello there. This video cassette will help you learn about the Lockheed CL-1201. With the new 1201, Lockheed will set a new standard for engineering innovation. But you probably have questions about how it'll all work, so let's jump right in.
Within hours of receiving a call for assistance, an attack carrier would be dispatched from an airbase in Georgia, bound for an aerial staging area over the Mediterranean.
Armed with 24 aircraft.
Airbase in Georgia. I'm assuming they're referring to the Georgia in the U.S. versus Georgia the country.
And long-range cruise missiles, the carrier's role would be to establish air superiority and function as a central command center.
7 logistics support aircraft would also be dispatched.
16 counter-air aircraft, as opposed to air-to-air, interesting, and close support aircraft, okay?
Central command center.
7 logistics support aircraft would also be dispatched to rendezvous with the carrier over the Mediterranean.
The logistics support aircraft, or LSAs, are giant aerial transports, each capable of carrying up to 400 combat-equipped troops, 472...
Okay, so there's the attack aircraft carrier variant and the logistics support variant. Okay. Also, they're putting the reactor right in the middle. I guess they need to find the largest portion to place something, because any type of reactor design is going to need to be heavily shielded, which normally isn't that much of a concern on the ground, but here, all of that added weight, it's going to need some powerful engine, which means the reactor has to be sized enough to hit a sweet spot where you got to make it big enough so it can lift the plane and lift itself with all the added weight of its own shielding. But if you make it too big, that'll just drastically increase the overall expense of the project. So there's an optimization function in there. Not impossible, but certainly impractical.
Specialized crew and over 1,000 tons of mechanized equipment, armament, and supplies to last for 30 days.
All 1201
30 days. That's a long time to be airborne, but for a nuclear reactor, that's a piece of cake. Nuclear reactors on the less exciting sea-based aircraft carriers and submarine go 20 years without refueling.
would be equipped with conventional landing gear and operate from paved runways. But for an aircraft of this size, the runway requirements would be absolutely massive.
Some big wheels,
so engineers proposed a novel solution.
For maximum operational flexibility, the carrier and LSAs will be fully equipped for short takeoff and landings.
I mean, yes, it's going to be short relative to the size of this aircraft just to find a runway that's big enough, but you're going to need some serious engines.
Dozens of auxiliary turbofan engines will be housed within the wings and forward fuselage, each capable of delivering an
Okay, how many? 82,500 pounds. So big, but not ginormous. But how many, though?
impressive 82,000 pounds of vertical thrust.
They're probably pretty big for back then. Some Rolls-Royce engines can produce over 100,000 pounds of thrust.
4 enormous high-bypass turbofans would supply an additional 600,000 pounds of thrust.
Okay, now we're getting into the really big stuff.
And allow the massive 1201s to cruise at about the same speed as a modern jet transport. But once
So those are the big engines, the rest are the auxiliary engines. All right.
over the staging area, the carrier and LSAs would need to loiter for extended periods, remaining continuously airborne for up to 30 days. So Lockheed's engineers turned to another unconventional solution.
Just patrol and be intimidating like a sea-based carrier strike group, I guess.
At the heart of every CL-1201 is a 30-foot diameter, 18,000 megawatt nuclear.
18,000? Okay, I think he meant to say 1,800 because that's what it said. 18,000 would be over twice as big as the entire nuclear power station that I worked at. And those aren't supposed to move. So 1830 megawatts and 2390 megawatts. To give you a sense of scale, so a Ford-class aircraft carrier has 2 reactors, fairly new A1B reactors at about 700 megawatts thermal apiece. So these reactors are considerably bigger, especially since they just mentioned 1. And this is comparable to commercial nuclear power plants back then. The nuclear power plant I worked at, 1 reactor was over 3,800 megawatts thermal, but that's a power station. This is a thing on a plane.
Nuclear reactor, similar to the kind already used on nuclear submarines, only
Except way bigger. Except way bigger.
much larger.
Yeah.
The Air Force and Atomic Energy Commission have spent decades testing.
I love the reference to the Atomic Energy Commission. So that no longer exists. It's the Nuclear Regulatory Commission as far as the regulation aspect, and the promotion aspect is under the nuclear arm of the Department of Energy now. But I love the throwback.
Systems for nuclear-powered aircraft engines. Now these technologies will finally come to a head. During takeoff and landings, the 1201's cruise engines will run on standard jet fuel and is only above 16,000 feet.
Interesting. So it uses jet fuel to take off. Why?
But they will be switched to nuclear power. Each engine is fitted with a heat exchanger.
If I had to guess, it's because nuclear power plants are designed to produce a lot of power, but not ramp up for the high speed and thrust requirements needed for takeoff. Especially because this reactor is more comparable to a commercial nuclear power plant. There you use a steady startup and ramp rate and then reach plateaus, and you'll gradually go from 0 to 100 on the order of hours to days. Just this is the size we're dealing with compared to a nuclear submarine that can start up very quickly. I guess they could have, but submarines don't need to fly. So that's my guess why they're going with jet fuel.
Can operate on either jet fuel or heat from the reactor. Coolant
Okay, so it essentially switches a mode selector switch for engine. That's kind of cool.
loops both inside and outside of the containment vessel will transfer heat from the reactor core while safely containing radioactive materials.
So they have 3 levels of containment, just like you would at a commercial nuclear power plant. Interesting here, they label it reactor vessel, then containment vessel, then neutron shield. So presumably the dose rate is far too high to enter the containment vessel, at least while the reactor is operating. And you're just a lot closer to the reactor compared to a commercial nuclear power plant where you have what's known as the bioshield, which is a zone within the reactor containment building that you cannot cross while the reactor is operating due to high neutron dose. But everything else looks pretty standard on paper. But again, your main challenge is small and light enough to fit into an aircraft, yet powerful enough to sustain flight. It's got to be very optimized to manage heat dissipation. Plus the addition of adequate radiation shielding, and radiation shielding for neutrons is heavy. Ideal materials for neutron shielding are concrete. The hydrogenous material slows down the neutrons and makes them a non-issue as far as health risks are concerned.
Radiation exposure will be limited by shielding and the reactor's containment vessel.
Okay, 0.25 millirems per hour, 20 feet from the outer surface of the shield. Okay, I'm glad we actually have a number for that. So 0.25 millirem per hour is a pretty low dose. To give you a sense of scale, you get 0.4 millirems during a flight from New York to LA, not flying on a nuclear-powered aircraft. Though this is 20 feet from the outer surface of the shield. That's a weird unit to give. When you look at radiological postings, most of them assume you are 30 centimeters from the source, or about 1 foot. And radiation follows the inverse square law, so you double your distance from the source, dose goes down by a factor of 4. Now, you're still on the outside of the shield, so the dose rate might not be that different between, say, 20 feet from the outer surface and 1 foot, because you're still on the other side of the shield, but that's a really weird unit. And radiation areas are not required to be posted unless the dose rate is above 5 millirem per hour, 30 centimeters from the source. And that's the lowest classification. Now, you'll often see them posted at dose rates considerably lower than that, just to be conservative, but that's still a weird unit.
Vessel would be housed inside an impact-absorbing structure. A minimum 16,000-foot altitude.
Good that it's impact and is absorbing. This plane crashes.
For nuclear-powered operations was selected on the basis that it would provide sufficient time for reactor shutdown in the event of an accident.
Interesting. But reactor shutdown should just take a couple of seconds, unless this is slower.
Engineers are confident that the reactor will be fail-safe even in a head-on impact with a granite mountain, assuming a prior...
It's interesting because granite is also slightly radioactive. Not sure why he mentioned granite, that's funny.
20-second shutdown warning. Now, how's that for safety?
It's actually pretty bad. 20 seconds is not very good by modern standards. That's like Chernobyl speeds. Though hopefully this reactor doesn't have graphite-tipped control rods, so you essentially hit the accelerator before hitting the brakes. But that's a different topic. Commercial nuclear power plants of a higher power output than this will typically shut down in less than 2 seconds. Control rods hit the bottom, the reactor shut down.
Along with the carrier and LSAs, a number of conventional...
So they just climb up little ladders in there? Is that what that is? It looks partially open. Wow.
Jet transports would also need to make their way to the staging area to support the assault force.
Over the staging area, the LSAs would be joined by smaller military transport aircraft referred to as medium inter-theater transports, or MITs. The MITs would rendezvous with the LSAs, docking in mid-flight to transfer troops, weaponry, and supplies.
I just love it. So many different sized aircraft can dock. Now, what's interesting is this is doing something that an aircraft carrier can't do. You're not seeing these big C-5 Galaxies or whatever these medium-sized transports are. You can't see those land on an aircraft carrier. I guess that's one other advantage that this crazy plan has.
The MITs would then connect to the LSAs via a tow line and remain on standby.
The 1201's blended wing design would make it an ideal platform for mid-air docking and transfer. And with the assault force in place, combat operations would begin immediately.
Working in conjunction with Allied forces on the ground, Carrier-based attack aircraft would clear enemy defenses to establish a secure airfield. Next, the MITs would begin shuttling troops
Small
and equipment between the LSAs and the airfield, protected by carrier-based fighter aircraft.
Aircraft this large would be high-value targets.
Yeah,
but Lockheed's
and a big
engineers
target,
weren't
too.
expecting adversaries to get anywhere near them.
Would you like to score a guns kill on something like this?
By operating at 30,000 feet and at least 600 nautical miles from hostile forces, it would be virtually impossible for the enemy to approach unobserved.
So it's going to fly like a little circular pattern, kind of like the Arsenal birds in Ace Combat 7 protecting the space elevator. That's funny. Now I know where they got that idea from.
But should the enemy attempt to engage, they'd have to contend with an impressive range of counter-air aircraft, long and short-range missiles, and of course, laser weapons.
After
What? Of course. I mean, laser, you got to. Does it also have nuclear weapons? I mean, come on. A nuclear attack carrier, and this is the Cold War, you gotta put, they like putting nukes on everything, right?
establishing a sizable presence on the ground, American troops working with Allied forces could stabilize the situation within
like
30 days and reopen the Mediterranean Sea for a larger, conventional ocean-going naval force.
I hope this video has proved informative. As you can see, the CL-1201 is an entirely new class of aircraft and a new means of delivering a rapid response strike to anywhere in the world.
I love it. I'll take 50. Nah, not really.
Keeping America and her allies safe.
It's not clear what prompted such an unusual design study. Was it a strategic threat, a need to assess the limits of aerospace technology, or was Lockheed simply keeping its summer interns busy? What's clear is that there are many unanswered questions. Not just technical and engineering, but basic questions like how the fighters were supposed to be rearmed during combat.
Pilot loading sequence. I like that.
Or how they would have docked with massive wake turbulence coming.
Yeah, that's got to be a massive jet wash. But it would just be vulnerable, high-value target. Well, unless it's equipped with something like this. If you're going to put in lasers, you got to have deflector shields too.
Coming off the carrier's wings. The deeper you dig, the more bizarre it seems to get. But without Lockheed's original report, we'll probably never get the answers. And in the context of the Cold War, the 1201 is just one of hundreds of highly speculative designs, many of which weren't really supposed to answer questions, but
there you go. And then you could have the 747's dock on the CL-1201, upgrading it to an airborne aircraft carrier.
help find the questions yet to be answered. But even among these countless conceptual designs, the 1201 stands out as one of the most unusual ever produced.
Also, the idea of flying nuclear reactors, I mean, its crew, you're going to need to have reactor operators up there, plus your pilots. I wouldn't think that's that big of an issue, just considering there's already plenty of reactor operators in the military at this point for submarines and aircraft carriers, but they just get to go on planes as well. And 30-day shift rotation for the crews with the smaller craft docking, that part is actually pretty standard, so they, at least compared to the shift rotation I was part of in a nuclear power plant. I wasn't in the military. I don't necessarily know what standard looks like then, but that part, I'm sure they could figure it out. But I don't know. A flying nuclear reactor, I know that's the most heavily shielded part of the aircraft, but it's a combat aircraft. It can get shot down. The reactor could get potentially damaged. But compared to an aircraft carrier or a sub, where the reactor, even if its containment vessels were breached, it'd be at the bottom of the ocean where water provides all the containment and all the heat sink you would ever need for really any man-made sized reactors. So if this thing crashes into the sea, it's fine. But if it crashes on land or is shot down on land and happens to fly itself directly into the position that shot it down, well, they're probably going to regret shooting it down and having it land right on top of them. Of course, forget the nuclear reactor. Its sheer size is going to cause problems. What a fascinating concept, and I really like the way they did the modeling and animations. It looks really cool, but unfortunately impractical. Thank you very much for watching. I'll see you next time.